Hi guys, welcome to a new video from AandGLearningLab. We are doing this video on temperature and what is temperature and what is heat and difference between them. Temperature is the physical quantity used to express hot and cold. It describes the average kinetic energy of molecules within a material or a system. But heat is the form of energy which describes transfer of thermal energy between molecules within a system. The unit of heat is joules, while the temperature is measured in Kelvin, degrees Celsius, Fahrenheit, Rankine, etc. Now let's see the specialities of these scales. Celsius scale. It is the most popular scale used to measure the temperature. It was originally known as centigrade scale. The Celsius scale is based on 0 degree for the freezing point of water and 100 degree for the boiling point of water in 1 atm pressure. It is named after the Swedish astronomer Anders Celsius, who developed it in 1742. Next one is Fahrenheit temperature scale. Fahrenheit temperature scale is the temperature scale that is based on the freezing point of water at 32 degrees Fahrenheit and the boiling point of water at 212 degrees Fahrenheit. It was defined by taking the freezing point of brine made from the mixture of ice, water and ammonium chloride. The other limit established was body temperature, originally set as 90 degree Fahrenheit and then 96 degree Fahrenheit. But the modern value of body temperature is 98.6 degrees Fahrenheit. Next temperature scale we see is Kelvin temperature scale. Kelvin temperature scale is an absolute temperature scale with 0 Kelvin at absolute zero. Absolute zero is temperature at which the volume of all gases becomes zero. Here we can see the graph of Charles law of a gas at a different pressure. The point where the lines meet is absolute zero. Difference of 1 Kelvin is the same as 1 degree Celsius. It fulfills Thomson's requirement as an absolute temperature scale. Now let's move on to Rankine temperature scale. The Rankine temperature scale is the temperature scale based on thermodynamic temperature, named after the Glasgow University engineer and physicist Macron Rankine, who proposed it in 1859. Just as in Kelvin scale, 0 degree Rankine is absolute zero. Temperature difference of 1 Rankine is defined as equal to 1 degree Fahrenheit. Consider this graph. We have plotted Celsius on x-axis and Fahrenheit on y-axis. We took freezing point and boiling point of water as known points. That is, x1 is equal to 0, freezing point of water in Celsius, x2 is equal to 100, boiling point of water in Celsius, y1 is equal to 32, freezing point of water in Fahrenheit, and y2 is equal to 212, boiling point of water in Fahrenheit. Let's consider a point TC and TF on the line by using two-point form. For calculating equation of the line, we get y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. By substituting values, we get TF minus 32 by TC minus 0 is equal to 212 minus 32 by 100 minus 0. Substituting values, we get TF minus 32 by TC minus 0 is equal to 212 minus 32 by 100 minus 0. Therefore, TF minus 32 by TC is equal to 180 by 100. TF minus 32 by TC is equal to 212 minus 32, which is 180, by 100 minus 0 is equal to 100. That is, 180 by 100 is equal to 9 by 5. So, TF minus 32 by TC is equal to 9 by 5. So, here we come up with an important relation. TF minus 32 is equal to 9 by 5 into TC. TF minus 32 is equal to 9 by 5 into TC. So, TF is equal to 9 by 5 into TC plus 32. So, TF is equal to 9 by 5 into TC plus 32. Let's find TC. TF minus 32 is equal to 9 by 5 into TC. So, 5 by 9 into TF minus 32 is equal to TC. Therefore, temperature in Celsius is equal to 5 by 9 into temperature in Fahrenheit minus 32. Temperature in Celsius is equal to 5 by 9 into temperature in Fahrenheit minus 32. Therefore, TF is equal to 9 by 5 TC plus 32 and TC is equal to 5 by 9 into TF minus 32. Let's revisit. We have substituted Tf minus 32 by Tc minus 0 is equal to 212 minus 32 by 100 minus 0. So we get Tf minus 32 by Tc is equal to 9 by 5. Tf minus 32 is equal to 9 by 5 into Tc. After that we get Tf is equal to 9 by 5 into Tc plus 32 and Tc is equal to 5 by 9 into Tf minus 32. Now let's see the relation between Kelvin and Celsius. We have taken the freezing point and boiling point of water as known points. Here x1 is equal to 0, freezing point of water in Celsius, and x2 is equal to 100, which is boiling point of water in Celsius. Then y1 273 Kelvin, which is freezing point of water in Kelvin, and y2 is equal to 373 Kelvin, which is boiling point of water in Kelvin. Here x is equal to temperature in Celsius and y is equal to temperature in Kelvin. By using the same formula, y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. We get Tk minus 273 by Tc minus 0 is equal to 373 minus 273 by 100 minus 0, which is equal to Tk minus 273 by Tc is equal to 1. From here, we get Tk is equal to Tc plus 273, which is temperature in Kelvin is equal to temperature in Celsius plus 273. Finally, we have got the three important conversion formulas. Tk is equal to Tc plus 273. Then Tc is equal to 5 by 9 into Tf minus 32 and Tf is equal to 9 by 5 into Tc plus 32. Let us see examples for that. Here, the temperature given is 20 degrees Celsius and we have to find the temperature in Kelvin. So we are using the formula Tk is equal to Tc plus 273. Here, temperature in Celsius is equal to 20. So temperature in Kelvin is equal to 20 plus 273, which is 293 Kelvin. Then, let's see second example. We have to find the temperature in Celsius. Here the temperature given is 96 degree Fahrenheit. So the temperature given is in Fahrenheit and we have to convert it into Celsius. So temperature in Celsius is equal to 5 by 9 into Tf minus 32, which is equal to 5 by 9 into 96 minus 32, which is equal to 35.556 degrees Celsius. Let's move to third example. The temperature is given is 37 degrees Celsius and we have to find the temperature in Fahrenheit. We can use the formula Tf is equal to 9 by 5 into Tc plus 32. By substituting, we get Tf is equal to 9 by 5 into 37 plus 32, which is 98.6 degree Fahrenheit.